Right triangle trigonometry, the two acute angles. As you can see, given in this problem is right triangle ABC. It's a 3, 4, 5 Pythagorean triple, right? One side, all three sides are given to us. We have a side of 3, a side of 4, and a side of 5. So we're going to start by setting up some trigonometric proportions, and we're going to start by using angle A as our reference angle. So if we're going to use angle A, that means this is our reference angle. And that means that if I put my little bow and my arrow, that means that this is going to be the opposite. This is going to be our hypotenuse. And this side over here is going to be our adjacent. So if we start setting up some trigonometric functions, we're going to start with the sine of angle A. Sine is so, opposite over hypotenuse. So we're going to have 3 over our hypotenuse, which is 5. And if we're going to do the cosine of angle A, then it's going to be our adjacent over our hypotenuse, which will give us 4 over 5. And if we do the tangent of angle A, it's going to be our opposite over adjacent, which is going to be 3 over 4. Now we could do exactly the same thing here with angle B. However, if we're going to use angle B, let me just make this a little bit thinner. If we're going to use angle B, then this is our reference angle. If we shoot our arrow across, this is going to be our opposite side, and this is going to be our adjacent side, and this is going to be our hypotenuse. So if we start making our proportions for angle B, our sine, so opposite over hypotenuse, is going to be 4 over 5. And if we do the cosine of B, it's going to be our A over H. So that's going to be our 3 over 5. And if we do the tangent of angle B, that's going to be our O over A, and that's going to be 4 over 3. Now, the main thing that we need to observe here and recognize is that there are some equivalent functions here. If you might have noticed that the sine of angle A has exactly the same proportion as the cosine of angle B, and the sine of the cosine of angle A has exactly the same proportion as the sine of angle B. And this is always true when those are the two acute angles of a right triangle. So the two things that we're going to remember are always true here is that the sine of angle A will always be equal to the cosine of angle B when they're the two acute angles of a right triangle. And the opposite is also true. The sine of angle B will always be equal to the cosine of angle A. This is always true when angles A and B are the two acute complementary angles of a right triangle. That will always be true. Now, a little aside note that I didn't talk about in too much in the lessons, and that is the relationship between the tan of A and tan of B. You might notice that the tan of A and the tan of B are reciprocals of each other. And one thing that always happens when you multiply reciprocals, say 3 over 4 times 4 over 3, is that you're always going to get a product of 1. So that's another thing that we can remember as a little bonus here, that the tan of A times the tan of B will always be equal to 1. That's also always true. Okay, but let's go back to the sine of A is equal to the cosine of B, and the sine of B is equal to the cosine of A. So if we look at the next page here, you'll see that I left a couple blank exercises. You can pause and try to fill in all of the proportions in each one of these that has the sine of one angle equal to the cosine of the other. So press pause. Okay, let's see how we did. So first we're going to, here in this first problem, we're going to do the sine of 50. And if we're going to use the sine of 50, that means this is our reference angle. That means the x is going to be our O. So we're going to say that the sine of 50 is going to be our opposite. Sorry, this is a bit awkward. Is going to be x over 13. Now, if we're going to make that equal to another function using cosine, we have to use this other angle up here, angle A. Well, one way we can always find the missing angle, the other acute angle of a right triangle, is to just say 90 minus 50. And that will be equal to 40, right? So we could just take 40 degrees right here and bring it up here. And now if we use A as our reference angle, we could plug in 40 degrees here. And then we could say, well, cosine is our adjacent over our hypotenuse, and that would give us x over 13. So you could see that the cosine and sine of a triangle will always be equal when the angles are complementary. So 50 plus 40 is equal to 90. Those are complementary angles. So the sine of one will be equal to the cosine of the other. The sine of 50 is equal to x over 13, and the cosine of 40 is equal to x over 13. One thing that you can always check in your calculator, if you look right there, I put in the sine of 50, and you can see it's a long decimal, 0.7660444431. And the cosine of 40, I also put in and hit enter, and it's equal to exactly the same, right? The sine of an angle will always be equal to the cosine of its complementary angle. All right, so let's look at this one down here. So here, this is really difficult to do here, but we're trying our best here. Did not want to do that. Okay, so here, I'm trying to click in here. All right, so the sine of 65 degrees will be equal to the opposite over the hypotenuse. So we have our x over 23. Now, if we're going to figure out the complementary angle, we're going to subtract 65 from 90, and we're going to get 25. So get 25 degrees should be in here. And 65 plus 25 is equal to 90. And the cosine of that will also be x over 23. Right? And in this problem over here, the sine of 42 should be equal to our opposite in this case, which is going to be 17 over x. And you can see if we went to the other angle, the other acute angle would be 90 minus 42, which would be 48. And the cosine of the other angle would be the a over the h, which would also be 17 over x. And then finally, over here, you can see that if we put in sine of 27, that's going to be equal to our 25 over x. And the cosine of the other angle is going to be 90 minus 27, which is going to be equal to 63. And therefore, cosine of 63 will be equal to, and the a over the h there would be my a over my h. So you can see for every trig problem we're using sine, you can also use the cosine of the complementary to do exactly the same thing. So more than one way to get the same answer. Okay, here are quick practice problems before we get to some regions problems. Some of these are pretty simple. And problem number 1, it's basically saying solve for x. Well, if sine and cosine are equal, that means the angles must be complementary. Let me write that down here. So that's important, right? If sine and cosine are equal, then the angles must be complementary. Sum to me. All right, so if that's true, then we can come over here. This is very difficult to do on my home computer. All right, and we're just going to say, well, if those are equal, then we can take 90 and subtract 67, which will be equal to 23. So x is equal to 23 degrees. Simple as that. And the same down here with this problem over here. X is going to be equal to 90 minus 12, because they must be complementary if the sine of one angle is equal to the cosine of the other, which is going to be equal to 78 degrees. Simple as that. Now here it gets a little bit more complicated, but not that much more. In this problem right here, they're saying that the sine and cosine are equal, therefore the representations of the angles must be complementary. So 2x plus 14 must plus an x minus 8 should be equal to 90 degrees. Let's add the x's and the numbers, and we're going to get plus 6 is equal to 90. We'll get 3x is equal to 90 minus 6. 3x is equal to 84. And divide by 3, x will be equal to 28 degrees. Right? No, 28. Now, there could be a problem, as you'll see in the near future, to figure out what each of those angles are. Well, one of the angles was 2x plus 14. which means it is equal to 2 times our x, which is 28, plus 14. 2 times 28 is 56, plus 14, which means that angle is equal to 70 degrees, and the other would be 20. Now, this last question is similar to a Regents question that you've already looked at. It asks, as the sine of x increases, the cosine of 90 minus x. Well, here the most important thing to remember is that if you have an angle and you're looking for its complement, you're going to take that angle and subtract it from 90. So if you have one angle that is x degrees, the complement will always be 90 minus x degrees. Therefore, this sine and this cosine have complementary angles, and therefore they'll always be the same. So as one increases, the other will also do the same because they are the same. All right, and here are some Regents questions. 21. For the acute angles in a right triangle, the sine of 4x degrees and the cosine of 3x plus 13 degrees. What is the number of degrees in the measure of the smaller angle? Well, we just looked at a problem similar to this. If sine and cosine are equal, that means those angles are complementary, which means I could add them up. And set them equal to 90 to figure out what x is, which means I'll have 7x is equal to 90 minus 13. 7x is equal to 77 divided by 7, and x is equal to 11. However, in this problem, they are not asking for x, right? So always be careful. Once you solve for x, look at C to see what the question is. Notice that 11 is one of the answers. They know that a lot of students love to just jump on the x answer. However, the question is, what is the number of degrees in the measure of the smaller angle? Well, I'm not really positive which one's the smaller angle until I substitute into one of them. So let's try the 4x first, the sine angle. That means 4x would be equal to 4 times 11, which would be equal to 44 degrees. Well, if one angle is 44 degrees, then the other is 46 degrees. They have to be complementary. Well, 44 is obviously the smaller one. I'm surprised they didn't put 46 as another answer. Nice to you there. And there you go. Simple as that. This is a problem that's really asking, did you understand this entire lesson? The most important point. Well, the most important point in this lesson is that when you have a right triangle, the two acute angles have a relationship in trigonometry, that the sine of one will always be the same as the cosine of the other. So quite simply, the answer to this question is 4. Well, here's another thing that we spoke about. Here it's saying, well, which one of these below will always be equal to the sine of x degrees? Well, they're all cosine answers. Well, the only time that sine and cosine are equal are when their angles are complementary. Well, if one angle is x degrees, the way that we figure out the other complementary is by taking 90 and subtracting whatever the angle was. Here it's x. So whichever one has 90 minus x degrees will be its complement and therefore equal. Here is a backdoor way of telling you that you have a right triangle and angle A and angle B are the acute angles. It does so by saying in triangle ABC, the complement of B is A. Well, if A and B are complementary, that means they add up to 90, which means that last angle, C, will have to be equal to 90 because we know that all three angles have to add up to 180 degrees. So really, this is asking the same question once again. If angle B and angle A are the two acute angles of a right triangle, then we know that the sine of one will always be equal to the cosine of the other. And finally, in triangle ABC, where C is the right angle, so A and B, again, are the two acute angles of a right triangle, which means the cosine of one will only be equal to the sine of the other when they are complements, which they are. Therefore, the cosine of A and the sine of B will always be exactly the same. So if the cosine of A is radical 21 over 5, so is the sine of B. And there you have it. I hope this lesson was useful, and I will post this as soon as I can. Bye, everybody.